Welcome. We're going to start now talking about potassium, Unit 7. And so there are 7 learning objectives that you all need to be familiar with to be prepped for the next exam that covers potassium, phosphorus and potassium, calcium, and magnesium. And in any event, we're talking about potassium, and the objectives are that by the end of this unit, you should know the functions of potassium in plant growth and the form of potassium taken up by plants. The second objective is to be able to recognize, actually, and diagnose potassium deficiency symptoms. And then objective number 3 is to familiarize yourself with the potassium cycle in soils. And that is related to being able to quantify the relative differences in the solution, exchangeable, non-exchangeable, and mineral potassium phases. Objective 4 is to understand the concept of potassium buffering capacity. And this term buffering should sound familiar. We talked about buffering in terms of pH back in the acidity and alkalinity unit 3 or 4. And I think it was unit 4. And potassium actually operates very similar to acidity in terms of buffering. And we're going to talk about that. Objective number 5 is to identify the soil and environmental factors that influence potassium availability to plants. And some of these you may be familiar with, and some of them you may not. Objective number 6, know the common potassium fertilizers and describe the behavior of potassium fertilizers when they're placed into soils. And then the last objective is to know the general guidelines for potassium management, including how we place potassium in the environment, i.e. in a soil that's being used to grow some sort of plant. And so with that said, let me give you some general information about potassium. And this is relatively recent information. You can find this at this website from Mosaic. And this shows you a simple list of the various types of plants or crops that we grow, and the removal of potassium expressed as K2O. All right, so potassium oxide. And there's a reason why this is expressed as potassium oxide, but can be easily expressed as just potassium. And if you look at the list, by and large, alfalfa and actually fescue, this would be some kind of tall fescue, lots of grass in a pasture, for example, in the form of fescue. Alfalfa, though, when I think of the crops or plants that remove a tremendous amount of potassium from the environment, I think often of alfalfa. And that's because alfalfa, and if you're familiar with alfalfa, alfalfa has a lot of leaves, and potassium plays a major role in leaves that we're going to learn about in this unit. So if you look across the board here, or this table, what you see is that the crops that we often grow really don't remove a lot of potassium from the environment. But we do have some crops that do, for example, alfalfa and fescue. But if we look at corn in terms of grain or silage, there's really not that much potassium that's removed. And so when we think about potassium, oftentimes your mind should come to alfalfa as the king of removing potassium from the environment. And in fact, this is something that probably won't describe in this unit at all, but if you were to quantify potassium availability in soils throughout a growing season under alfalfa, what you would see is at the very beginning of the growing season, the potassium concentrations in the soil, extractable or plant available, potassium concentrations would be relatively high. And as you go through the season, they actually drop because of alfalfa being removed with likely several cuttings throughout the season.